This video is just to talk about sound and the way that we represent sound and store sound on a computer. So the first thing we really need to think about is the idea of what an analog signal is, what analog is in general. So analog is the way that humans do things in general terms. So we hear things in an analog way. So when we hear a sound, it's because our eardrum is moving in response to the sound wave that we hear. So there's a varying pressure wave that's created when someone speaks, or when you hear music, or when a hammer hitting on a nail or something like that. Any kind of sound is a continuously varying analog wave. So analog signals continuously vary. So it doesn't matter what analog signal it is, it's going to be a continuously varying value, and we can have some ideas of things that are analog, such as analog clocks or a speedometer on a car with a needle that keeps moving in response to the speed. All of those things are analog. Computers live in a digital world, so they're digital. So they only store numbers. In fact, they only store binary numbers, and that's a digital representation. So the computer can't store an analog signal. It has to store a digital representation. So the way that we create that is to convert the analog signal into a digital representation of that signal. To do that, we use this thing called an analog to digital converter. You'll sometimes see that reduced to the idea of ADC, analog to digital converter. And we do that by sampling the sound. So what we do is take a measurement of the amplitude of the sound at a given point, and we do that at regular intervals. So we'll sample the sound at regular intervals. So regular intervals are sampled, and the number of samples per second is called the sampling rate. So we generally sample a lot of times per second, and you'll see in a short time how many of those that we do use, but normally it's several thousand samples per second. And then we assign a digital value to each sample. So you can see on this side that I've got 4 bits that I'm using to represent each sample. So we know that 4 bits in binary 1, 2, 4, 8. We know that the biggest number we can put in that is 15, and that we can also put 0 in, so we've got 16 different levels. So 16 levels of sound, which is not a huge amount, it's quite a small amount for representing a sound. And you'll see that the 3 bits right at the top of here, these 3 samples, are all probably going to be 1101, because we have to put them to that one or the one below, because we can't go in between. We don't have anywhere to put them. So therefore, our sound is not going to be as accurate as the original sound. So this idea is called quantization error or quantization noise, because this whole process is called quantization. Quantization. So we're adding quantity to our analog signal, basically. So we're quantizing it, giving each bit a quantity. So the digital value is assigned to each sample taken, and then we store that value. So obviously, if we've got more binary bits per sample, we can be more accurate, as we've just said. So more binary bits. If I added another one, we know that that's 16. It's going to make me 32 levels. And this is why binary ties into all of this representation. So we add another bit, we can get 32 levels. So we're going to be more accurate again for that. So the number of bits we use per sample is called the sampling resolution. So there are 2 things that we need to think about when we're sampling a sound, and that's sample rate, and that's measured in samples per second. And we've got resolution, and that's in bits. So how many bits per sample that we're going to use. So when we record a sound, we record it from the analog world and then convert it using an analog to digital converter. If we want to listen to that sound once we've put it onto the computer and stored it, we have to convert it back to analog because our ears are analog devices. So we convert it back with a digital to analog converter and we reconvert that sound back into something that can be heard by humans.